Hello friends, in this video we will learn conversion of decimal to binary, octal and hexadecimal. This Python program converts decimal number into binary, octal and hexadecimal equivalent using concept of object-oriented programming. In first step, we create a class named number converter. This class contains all functions requires to number conversion. And in this second step, the constructor initializes three variables: self original stores the original number entered by user, self num stores the absolute value of the number so that conversion becomes easier, and third, self neg checks whether the entered number is negative. It stores true if the number is negative, otherwise false. In third step, binary conversion to binary, a method we have created here. To binary method converts the decimal number into binary. If the number is 0, directly it returns 0, otherwise it repeatedly divides the number by 2. In each iteration, it stores the remainder 0 or 1 at the beginning of the resulting string. You can see here we are prefixing or we are adding it at the left side of the string. The division continue until number becomes 0. In this return line, if the original number is negative, then minus sign is added before the binary result, otherwise as it is. You can see here. In the fourth step, octal conversion to octal, a method is created here. Octal method works similarly. If the number is 0, it returns 0, otherwise it repeatedly divides the number by 8. The remainder contains each step becomes an octal digit. Whatever be the remainder, it will be an octal digit. These digits are added in reverse order to form the final octal number. A minus sign is prefixed if the original number is negative, otherwise result will be as it is. In the next step, the to hex method converts the decimal number into hexadecimal. If the number is 0, it returns 0. A string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, uppercase A, B, C, D, E, F is used to represent hexadecimal digits. The number is repeatedly divided by 16. We use the while loop here, same as in previous methods. Each remainder is used to obtain the corresponding hexadecimal character. Here we are using indexing of the hexchar string. Characters are added in reverse order to form the hexadecimal number. If the original number is negative, minus sign is prefixed, otherwise result remains as it is. Same type of steps we have used in all these three methods. Now come to the main program part. In the main program, the user enters a decimal number. This line accepts user input. An object converter created for the class number converter, and the program calls three methods: to binary, to octal, to hex. Finally, the converted values are displayed on the screen. We are using the print functions for these three lines. This program converts a decimal number into binary, octal and hexadecimal. Let's check whether the program is working or not. We will run this program and we will give some input. Suppose we give an input 9999, 4 times 9. Let's see the output. This is the equivalent binary and octal and hexadecimal. Let's check for some negative number. Suppose I enter 999, 4 times 9. You can see the equivalent conversion. And let's see for 0 input. Here you can see equivalent binary number is 0, octal 0, hexadecimal 0. Means 0 remains 0 in all the number system. You learn something from this video. Please write comments on the video. Thanks for watching.